one because it was simple and we were able to follow through with no difficulties. 33 it is. 33. Good. Let me copy it. 33 on 413, I think. So y equals 2x squared minus 6x plus 5, and y equals x squared plus 6x minus 15. Of course, this is a different story because these are both quadratic functions, and I have a big theory on graphing those, right? It's not, it's going to be a plug and chuck, right? Okay, so let's start with the first one. So y equals 2x squared minus 6x plus 5. When x is 0, I get y equals 5. So that's the y-intercept. Now when y is 0, I get 2x squared minus 6x plus 5 equals 0. I have to use the quadratic formula. Negative b plus or minus b squared minus 4ac, nice, over 2a4, not real. Thank you. Okay, these are not real numbers. So, which means the quadratic function, because it has a leading coefficient which is 2, it will have a minimum. It will have a minimum and it will not cross the x-axis. There are no x-intercepts. No x-intercepts. Not a real number. But I have to find the vertex. We graphed these functions a long time ago. So remember the... Can anyone remind us of the x-coordinate of the vertex? Anyone? Awesome, thank you very much. So negative b, negative 6. 2 times a, 2 times 2 is 4. So this is 3/2. Okay? So now I have to plug in 3/2 and see what this is. So y is 2 times 9 over 4 minus 6 times 3 over 2 and plus 5. Okay, can I simplify a little bit? Yes, I can. So this is 9/2. I'm not going to simplify here because I want the same denominator. Minus 18/2 and plus 5. So negative 9/2 plus 5, so that's 10 minus, so this is 1/2. Okay, after all these calculations, I have the graph. So to speak, in a blink. So 1, 2, 1, 2. Okay. So 3/2, 1/2 is this. This is where the axis of symmetry of the graph is. And it crosses at 5. 1, 2, 3, 4, 5. So here's the first graph. As symmetric as you can. So this is y equals 2x squared minus 6x plus 5. We repeat all these steps for the other one, which is x squared plus 6x minus 15. X squared plus 6x minus 15. So I have y equals, it's first x equals 0, y equals negative 15. So 0, negative 15. When y is 0, x squared plus 6x minus 15 equals 0. I have to find the x-intercepts. Negative b plus or minus b squared minus 4ac. 4 times 15 is 60 divided by 2. So negative 6 plus or minus, this is ugly, 96 over 2. I have to approximate these solutions. So do I have my calculator here handy? Yes. So I have to approximate parentheses, don't forget. negative 6 plus the square root of 96, and then close the parenthesis and then divide by 2. And then the other one with minus. So I got x equals 1.9 and x equals negative 7.9. Okay. I need a vertex, and then I'll graph it. Negative b over 2a, negative 6 over 2, negative 3. And then I have 9 minus 18 minus 15. Yeah, I had to get all these large numbers now. Okay, so this is 33. So 9 minus 33. So y equals negative 24. Okay, so negative 24. Fine. So this still has a, looks like this. It opens up because the leading coefficient is positive. But now, negative b over 2a, just checking here. This was negative 3x, correct. Okay, negative 33. Yep, negative 24. Okay, so 1, 2, 3, negative 3, negative 3 is somewhere here. Okay, 0, negative 15, 0, negative 15. Okay, 0, negative 15, and 1.9. So this was 1.5. Here's one intercept, and the other one is at negative 7.9. I have to graph everything one more time. So it looks like something like this. Let's find the points of intersection before I graph it one more time. Yeah, some of these problems are not very friendly, as you see. So let's find the point of intersection before I do anything. We have an idea of the graph, so okay. I'm going to copy the two functions so we can find the points of intersection. We are going to set them equal to each other. So 2x squared minus 6x plus 5 and x squared plus 6x minus 15. So once we set them equal to each other, 2x squared minus 6x plus 5 equals x squared plus 6x minus 15. From here, no equal symbol. We cannot have more than one. I will move x squared, so I have x squared. I will move, so I get negative 12x, and I will move this, and I get positive 20. And this is nice because it factors very nicely. So x equals 2 and x equals 10. So the two graphs intersect between 2 and 10. But I still have to have a graph, and we can, because the numbers are weird, so somehow they intersect when x equals 2 and when x equals 10. When x equals 2 and x equals 10. Yeah, I don't have a clear picture before I graph it. So let's do this for a second. I'm going to share my screen. So in y equals, where is my calculator? Right here. So in y equals, let's put these two functions in. We did our homework in the sense that I know where the graphs are. So then 2x squared, 2x squared, and then minus 6x plus 5. That's one. And the other one is x squared plus 6x. So x squared plus 6x. Oh, 1 second, I have to plug in my computer. It's dying. The battery is dying. I just saw that. Okay, x squared plus 6x and minus 15. Okay, so I know that I'm really interested in the interval 2 to 10 because I know where the intercepts are, but I just want to use different windows so I can see both graphs. So I'm going to go to negative 40 to 40 with a scale of 4, let's say. And I know that the vertex is at negative 24, so I'm going to have at least, let's say, negative 40 to 40 also. If one of them has the vertex and crosses, so with a scale of 4 as well. I want to see the graphs. Here they are. Aha. So because of the numbers quite large for the other one, I had to reconstruct the graph. But now I see what's happening here. So the intercept is, so I'm going to even increase the y value. So the y value, I'm going to say 100. Oops, 100. So now I can go back and minimize. I don't really need all this. I really need between 0 and 10. So I can still allow a negative 4 to 15, but I know where the intercept is now. So a y minimum, 0 will be okay, 100, but I'm going to change the scale to 10. So I can see the interception, the area between those curves. Aha, it's even higher than 100. So, okay, I'm going to go to 500. I probably, it's too much. 200. Okay. I just want to see that area. Here it is, finally. So this is this little sliver right here. That's the intersection between x equals 2 and x equals 10, which we knew. Why I need to see the area? First of all, I have to have it on paper. And secondly, I want to know which one is above. Which one is above, which one is below. It's not a big deal because if I get a negative number, then I know I reversed them by mistake. So then the answer cannot be negative. But I have the above. The above is the second function. It's in red. The second function is above, and the first one is below. Okay? So this is the x squared plus 6x minus 15, and this one is the 2x squared minus 6x plus 5. Okay? Yep, because the numbers were all over the place, sometimes I knew what I was looking at, but I wanted to see the correct graph, and we found the intercepts. So now the exact area is the integral from 2 to 10 from x squared plus 6x minus 15, that is above, minus 2x squared plus 6x and minus 5 dx, and that will be the below. So then first I have to clean it up. So I have this with this, so this is negative x squared. Then I have these two, positive 12x, and then I have the negative 20 dx. And now this is just plugging in. Plus 12x squared over 2, minus 20x from 2 to 10. Okay. So I plug in, and now it's more complicated because I don't have 0 as the lower limit. I love those with the 0 as the lower limit. Okay, I have to plug in 10 minus 1,000 divided by 3. This is 6 plus 600 minus 200. But now minus, put parentheses so you don't forget to distribute a negative sign. 2 here, negative 8/3. 2 here, 6 times 4, 24. and 2 here is minus 40. So after calculating all this, let's see what we get. Okay, so negative 1,000, oh, that's almost dead. 1,000 divided by 3. 600 minus 200, 400. This becomes 8/3. And 24 minus 14, minus 40 is negative 16, so positive 16. Okay. So this is negative 992 over 3 plus 416. So this needs a 3. So negative 992 plus 8 and 1, 4, 12, okay, and 1248, 992. So I got 6 and 5 and 2. So 256 divided by 3. That's the area enclosed by those two graphs. So yes, now I can go back and correctly graph the two. So they are intersecting right here, something like this. Very good. We still have a few minutes. I'd like to at least start a word